Today we are joined by Maria Hayes, who's a research officer from Teagasc, and she's here to talk to us a little bit about her work as project coordinator for the SEASOLUTIONS Project. So Maria, thank you very much for joining us today.
No problem at all, Sarah. Thanks for having me.
No, it's great to have you. So I was wondering if you could tell us a little bit more about SEASOLUTIONS and what the project's about.
Sure, yeah. So SEASOLUTIONS is a project it's a very exciting project that just started the start of 2020. Unfortunately, we were impacted by COVID-19, but yeah. we've still made progress, thankfully. So the aim, I suppose, and what we want to do within SEASOLUTIONS is to basically use seaweeds and seaweed ingredients and formulate them into feeds for cattle, sheep and dairy cows, to basically reduce methane emissions from these animals and to have more sustainable production in our agri-sector. So really combining marine with the agricultural sector and hopefully create jobs in both sectors and continue to produce excellent food here in Ireland and across Europe.
It's kind of this blue to green transition, really, isn't it?
Exactly, yeah. So it's all about really screening for actives. So that work is carried out here in Teagasc Ashtown. So we take the seaweeds and we basically select seaweeds based on their availability from sustainable harvest or whether they're produced through aquaculture. And then we screen them for different actives that we think can inhibit enzymes important in methane production in the rumen of these animals, cattle, sheep and dairy cows. And from there then we generate methodologies to extract actives and combine them into feed ingredients. And then we also have a number of animal feeding trials. So we trial our ingredients in vitro in an artificial rumen, and that system is called a RussiTech. And that work is carried out at Teagasc Grange. And then we have a sheep feeding trial, or sheep feeding trials, I should say, in Grange here in Ireland and in Norway.
Okay. Yeah.
And we have a beef trial here in Grange as well, and then also in Canada. And we have dairy feeding trials in Aspby in Northern Ireland and in SLU in Sweden, and also one in Germany. So yeah, it's a big consortium and a big challenge, I suppose, to really come up with something to reduce methane emissions. And to date, we've screened maybe 72 different seaweeds, and from those so far we have possibly 2 potential ones that we're hoping to bring further and to hopefully commercialise. So
fantastic. And actually, it's great to have kind of partners in the consortium from really all over the world. It's in that sense.
Yeah, it's an EU funded project, I suppose, but the funds are awarded by Europe and then by national governments in Canada. So we have some great expertise in animal nutrition in Canada in the University of Alberta, and people who have worked on this for quite a while, so they've vast amount of experience to bring to the project. So yeah, it's going well so far.
Yeah, there's a lot going on.
Exactly,
and tell me, so how would this research be used by the Irish aquaculture sector, or what will the outputs do for them?
Yeah, so at the moment where the quantities of seaweeds that are required for use in animal feed to reduce methane emissions, even though we're maybe only adding the seaweed or the seaweed extract at concentrations to the diet of between 0.5 to 4% maximum, we require an awful lot of seaweed or extract to do that. So we would hope that going forward that seaweeds that are active could be produced at scale using aquaculture, and that we would have a sustainable supply of that seaweed on hand, because currently we're focused on seaweeds that are sustainably harvested and that are present in abundance. But I suppose to ensure sustainable supply, aquaculture would be ideal. So that's how I'd see the link there, between the two sectors.
Yeah, and I guess it's kind of more targeted farming in a sense, because you know exactly what species you need and then the quantities as well.
Yeah, exactly. And with different methods, we'd hope to be able to enhance certain bioactives within the selected seaweed or seaweeds, and be able to produce them at quantities that are required, because the population of animals in this country is more than humans. So, you know, you do need a sustainable supply of that biomass. And I suppose the solution to that is either aquaculture or sustainable harvesting. But, you know, the aquaculture aspect could do away maybe with variability in actives and things like that as well.
Yeah, I know. Yeah, you need that control in your raw materials. You need to know exactly what you're going to have in. Yeah, no, it's really interesting.
Yeah, so like I know at the moment, like a lot of species that are produced through aquaculture are used for food use really, or, you know, maybe horticultural applications. So we'd hope that the information coming from this project could really influence what species are focused on in terms of aquaculture. Yeah,
so you're really shaping the kind of the future of the industry in a sense.
Yeah, well, I go that far, but yeah, we're hoping to solve. Our first aim, I suppose, is to solve the methane emissions aspect, and then, you know, there's bound to be benefits hopefully for the marine sector and aquaculture sector once we solve that issue. But that is our main focus: reduction of methane emissions from dairy cows, cattle, and sheep, and seaweeds, you know, from our research to date are good candidates for that. But obviously there's no silver bullet in anything like this. You know, it requires research, and it requires that we're sure of what seaweed is giving us a positive effect, and then that we can produce it through, you know, in sustainable quantities. So,
and you mentioned before that you've kind of found a few kind of isolates. I'm not sure what the exact term should be that'll work. I'm just wondering in general what stage of development the research is at.
Yeah, so we have, for the last year and a bit, we've been screening the different seaweeds and characterising them for these bioactive ingredients. And we're doing that here in Teagasc in Dublin, but also in IT Sligo over in the west of Ireland, and we have partners then in Norway as well, looking at different aspects. So to date we've characterised 72 seaweeds in total, and then we have also we've also trialled some of these seaweeds in our in vitro artificial rumen to see if we can reduce methane emissions with these ingredients. And from that point then, 20 or so seaweeds were selected for potentials for use in animal trials. So we've taken the best of those seaweeds and a seaweed extract generated from a different seaweed, and we've carried them through to our first animal trials, which are sheep feeding trials. So we've completed one sheep feeding trial to date, and the results are positive with one seaweed and one extract. We should have more results from another separate feeding trial focused on different seaweeds before Christmas, and then at the start of next year we're carrying out a beef trial, and then dairy trials in 2022 as well. So we should get a bigger picture. I should say we're also assessing the effect of all these extracts and everything on the rumen microbiota, and what bacteria are stimulated or inhibited within that system. And we're trying to basically formulate the actives into feed delivery formats as well, because that's important. So that's really where it's at the moment. We still have a number of animal trials to complete, but we have some initial hit seaweeds, if you like, and hit extracts that are showing promise, definitely.
It sounds like there's so much going on within the project.
It's a busy project, and hopefully it'll solve the problem. Everything, that's what we all want, really. And
I was just kind of wondering, so how does that research compare to other research being done at the moment?
So a lot of great work has been done on some seaweeds in Australia, and research from Canada as well, and even in Ireland. So people have been looking at the red seaweeds, Asparagopsis species, Asparagopsis taxiformis and Asparagopsis aromatica. And I know there's a big drive to basically produce those seaweeds through aquaculture as well. Our focus is not on Asparagopsis because, a lot of the animal trials carried out to date have shown that it is very effective at reducing methane. But there are caveats with the active, which is bromoform, in that it is thought to be carcinogenic, and also cultivation at scale and release of halocarbons is thought to have a negative impact on the ozone layer. So for us, we decided not to focus on that, but also for us, we found it very difficult to get that seaweed in Ireland, you know, either Aspergillus taxiformis or Aspergillus aromatica. So for that reason, primarily, we focused on different seaweeds, you know, based on alternative actives other than bromoform, because in our mind, we didn't want to focus on that because some work has been done on it already, but we think that there is negatives with it, you know, based on our literature searches and etc. So for us, we just decided to focus on different, more sustainable seaweeds that we can actually get in the volumes that are required to carry out these animal trials.
Yeah, no, it's fantastic.
Yeah, so like that said, like Aspergopsis, there is very significant methane reduction with Aspergopsis that has been observed in several studies globally, you know. To give an example, another example, like there's a chemical compound called 3-nop that's out there as well, that is thought to reduce emissions by up to 40%, 45% in some instances. And I think that's actually at the EFSA stage of approval. It's being reviewed by EFSA currently to reduce emissions. So yeah, that's how it really stands, I suppose, compared to the others. So our reductions are, you know, they wouldn't be up on 40%, but so far we've seen reductions of like 12 to 20%, and we're hoping to enhance that further through, you know, refining the active within the seaweed. But you know, the thing with seaweed is that the ones that we're using are already considered feed grade, and they're considered beneficial for the animal for other reasons. So to us, it seems like a win-win if we can reduce methane with those species, and you know, we can also increase maybe body weight gain and the health of the animal. You know, so that's our focus is more on that.
Yeah, no, and you're right. Like, it is a real win-win if you can like boost animal nutrition and health on the one side, and then like lower.
Yeah, exactly. And just, you know, especially in Europe at the moment with, you know, the European policies regarding antibiotic use in animals and things like that. So things that maybe have anti-helminthic activity or, you know, health benefits for the animal, it's a plus as well if we can reduce methane emissions and improve animal health, you know. You know, and also the, you know, natural ingredients in the food chain, it's the nice concept, you know, and it's something that's popular at the moment as well.
It's a bit better for everyone, really, sort of humans and animals in that sense.
Yeah, exactly. Well, so far we think that, you know. You know, exactly.
And then kind of what are the next steps for the research? So you have a few trials going on. And then
so our next steps with the SEASOLUTIONS Project are really to identify fully the actives which we have found activity with so far, and then to continue screening other seaweeds that we haven't finished with yet to see if they reduce emissions. But I suppose most significantly at the start of next year, where we will be carrying out our animal trials in dairy and beef with the actives that we have found from the sheep trial. So they're the next steps really with the project. And then we also hope to have an open day in March, maybe next year, for industry, and to disseminate our findings to industry and other interested stakeholders at that point. That's where it's at currently. But yeah, so far we've made some good progress, I think, all things considered with COVID, etc. So we're happy that we have some initial hits, and we want to just fully characterize them before we kind of release what you know, their mechanisms of action and things like that. It's important to do that as well.
Well, it's great, and it's really exciting, and a few busy months ahead with all of the trials as well.
Yeah, you could say that again.
For sure.
Very busy.
And Maria, tell me, if someone wanted to find out more about your work and the SEASOLUTIONS Project, where is the best place to go?
Yeah, so if anyone is interested in the project, feel free to contact me, or you can consult the SEASOLUTIONS website, www.seasolutions.ie. And yeah, I'd be happy to take any questions from people who are interested in hearing more about it.
Yeah, that's fantastic. And what I'll do is I'll share those details on the IATIP website as well.
Okay, brilliant. Thank you.
Brilliant. It was great chatting to you this morning and just to hear a little bit more about everything that's going on. And I just want to say, well, thank you for your time, first of all, but best of luck with the trials now. It's really interesting research, and
Yeah,
it'll go
definitely.
well.
Maybe we can chat again when we have some more trials
Yeah.
completed, and an update on those. Hopefully it will be positive. So
yeah, it'd be lovely. And it'd great to touch base maybe in March as well with your brokerage event that you have coming up.
Yes, definitely. Yeah. I can share the details of it with you, and happy to disseminate it broadly.
Yeah, that's great. And we can always share that with the ATIP or the IATIP community as well. So that's fantastic.
Brilliant. Thanks very much, Sarah.
And thanks a million, and we'll chat to you soon.